Okay, so here we're adding in scientific notation, and I think the biggest observation for me personally when I do this is to realize that we can add these numbers directly if the powers of 10 are exactly the same. For example, if I have 300 and I have the number 30, right? Plus 30. You know that this is 330. But in scientific notation, I hope you wouldn't get confused because 300 is 3 times 10 squared, and 30 is what? That's 3 times 10 to the first. So notice, these are the same scenario. You wouldn't just add 3 and 3 to get 6 and somehow add this, right, to get 10 to the second, 10 to the third. What would you even get? Right? You can't add these two 3's because they're in different place values. So in order to add them, one way to quickly do this is to rewrite one of the two numbers in the correct form. In other words, write it in a way so that the powers of 10 are the same. We're adding here, I'm going to choose the higher exponent. So we have 3 times 10 squared, I'll leave that one. And the bottom one, I'm going to rewrite it using 10 squared. All I have to do is make it 0.3 times 10 squared. Right? If I make 10 to the first 10 squared, that means I'm multiplying by 10. So here I'd balance it by dividing by 10. Now I can basically add these. It's 3 plus 0.3. In fact, I'll write it, down here. That's 3.3. And here, 3.3. It's 10 squares, right? We just leave that. It's 10 squares in terms of 100, right? Just like our answer here is 330. That's what we get here as well. And if you're still not convinced that you don't have to add these 10 squareds, like why don't we add them? What's going on? Think of algebra. In algebra, if I had 3x, you can think of this as 3 times a number, x. This down here is a different number, 0.3 times the same number. So it's 0.3x. If you add up these two terms, you would just get 3.3x, right? You wouldn't add the x as well. That's the same idea. If I had, another example, if I had 5x plus 6x, that would give me just 11x. Again, I just add those coefficients. The same idea is happening here. So when I deal with these sums of these larger numbers, I'm going to use the same strategy. I'm going to get this exponent to match the 29 here. So how am I going to do that? Well, here I'm going to raise it by a power of 10, so it's 10 to the 29th. And here I'll divide it by 10, it's 0.45. And here, now I just line things up, 1.45 times 10 to the 29th. And I add these two. And I'm basically done because now this is 1.8 and this is 10, so I carry the 1. This becomes 9, so I'll just backtrack. Sorry, 5 plus 5 is 10. 4 plus 4 is 8, plus 1 is 9, times 10 to the 29th. So I would write this finally as 1.9. The zero is not needed, doesn't change the value, times 10 to the 29th power. All right, thanks.